Hi, in this video we are going to see about a Python IEEE project which is entitled as AI powered cattle breed recognition using deep learning, which is an enhancement of IEEE base paper title Cow Analyzer Visual Features Based Smart Breed Identification Application, which is an IEEE 2025 conference paper. And also this project is also listed in the Smart India Hackathon 2025. If you go to Smart India Hackathon 2025 official website, if you go to problem statements, you can see the fifth problem statement, which is under the department Ministry of Fisheries, Animal Husbandry and Dairying. You can see image based animal type classification for cattle and buffaloes. We have implemented more the thing that is mentioned also. So before seeing the execution of the project, let me brief about this project. So we all know agriculture is an important backbone for several countries, and especially countries like India, where agriculture is the major occupation. And the cattle also plays an important role in agriculture, helping the farmers. In India, the cattle like cows and buffaloes are utilized in the agriculture, and there are different types of breeds are available in the cattle. Only the experienced person who involved in it can able to identify it. Other than that, a new person, if wanted to identify the breed of it, they cannot able to identify it because some of the breeds may look similar also. To overcome this issue, in this base paper, the authors have implemented the visual feature based smart breed identification application, where here in the base paper, the author from Pakistan have taken the 10 Pakistan cattle breedel, and based on the color, pattern, structure, shape, these kinds of features, they have implemented the identifying the breed. And here you can see the details of the breeds that they have used: Brown Swiss, Colastini, Haryana, Jersey, Holstein Friesian, Kanraj, Nili, Ravi, Red Sindhi, Saiwal, Tarparkar. So these are all the data set that they have taken in the base paper. So now we are not going to implement the same as mentioned in the base paper. So now let us see about our proposed system and how we are going to improve the things that is mentioned in the base paper. So here you can see the proposed title, that is AI powered cattle breed recognition using deep learning, and this is the IEEE base paper title, and this is the IEEE base paper abstract. So coming to our proposed project abstract, so here we have implemented the AI powered cattle breed recognition using deep learning, which is developed using Python as the primary coding language. And for the front end, we have used HTML, CSS and JavaScript. For the web framework, we have used Flask. So here the implementation model that we have used is YOLO V8 deep learning architecture. So here the data set that we have taken contains 4,803 cattle images, where the 4,179 images or training images, 390 or validation images, 234 are testing images. So here we are going to cover 32 cattle breeds. So base paper takes only 10 cattle breeds, but we are going to improve by using 32 cattle breeds, and those 32 cattle breeds are Alambadi, Amriti, Mahal, Bunny, Burgur, Brown Swiss, Gir, Gursarsni, Haligar, Holstein Friesian, Jersey, Congayam, Saiwal, Tarpakar, Vechur kinds of breeds that we are going to consider. So before moving, let us see about the dataset images I will show you. So here we have given you the train images. So here you can see 4,179 images. You can see it contains the 32 breeds of different cattle breeds with the different positions and postures of it. And as mentioned in the validation of the images, which contains 390 with the valid test images. You can see those images are listed here, and in the test part we have given about 234 images. So these are all the images about the project. So now The next part is about the model. So the model that we have used is YOLO V8 model. So what accuracy that we have achieved is training accuracy of 80% and validation accuracy of 73. So as we have used YOLO, here the performance analysis parameter will be mean average precision, MAP, at 0.5 is our evaluation parameter, which is around 73%. So we have used around 32 cattle breeds, and in the project we have implemented two different modes. One is image based mode, so where the user can able to upload the image and they can identify the breed. Next one is the real-time breed. Real-time means you can use your web camera, and using your web camera you can just show the cow or the buffalo, it will be identifying the breed of it. So there is no external hardware required. You don't need any specialized hardware. Just using your laptop camera or additional web camera in your PC, you can able to achieve this. And also we are going to provide a voice output. So in the voice output we are going to use 4 different regional languages. So here English output, in it will be detecting the breed, and also it will be saying about the breed information in English, Tamil, Telugu and Kannada, Hindi kinds of thing. I'll show you those in the output part of it. So all these details have been mentioned in our proposed project abstract. Coming to the existing system, so we are going to consider the base paper as the existing one. So here the existing system is about the cow analyzer model, where they have used the morphological characteristics based on the color patterns, facial structure, horn shape, arm size, ear length kinds of thing they have used. So they have used these features and key extraction features like local binary pattern, histogram of oriented gradients are utilized to capture the texture and gradient information from the cattle. And then they have utilized the YOLO model and they have implemented it. So these are the things that is mentioned in the existing system of the project. Now coming to the disadvantages of the existing system, the main disadvantages of the existing system are limited number of supported breeds, because they are covering only 10 cattle breeds. Next disadvantage is dependency on handcrafted feature extraction. Next disadvantage is lower classification accuracy. Next disadvantage is no real-time voice output or assistant feature. Next disadvantage is limited real-world deployment capability. And next one is scalability limitation. These are the main disadvantages of the existing system. Now coming to the proposed system, to overcome all these issues that is mentioned in the existing system, we have proposed the AI powered cattle breed recognition using deep learning, which is developed using Python, Flask, HTML, CSS and JavaScript. And we have used YOLO V8, you only look once version 8 architecture. Here we have used 32 different breeds of cattle, and the training dataset contains 4,803 cattle images. So here the proposed system operates in 2 different modes. The first one is image-based breed identification. User can upload the cattle image and the system will process it, and it will be showing the breed of it and the information of it. And once the breed is identified, it also gives a voice information about the breed, and user can select the language like English, Tamil, Telugu or Hindi kinds of thing. Next we have utilized the real-time web camera detection. So using your available web camera, you can just show the live feed, and based on the information that is shown in the camera, it will be identifying the breed of it. So these are the things that is mentioned in the proposed system of the project. Next, coming to the advantages of the proposed system, the main advantages of our proposed system are supports a large number of breeds, higher accuracy with deep learning, real-time detection capability, multi-language voice support output, user-friendly web interface, automatic breed information display, scalable and extensible. These are the main advantages of our proposed system. Now let us see about the system architecture. This is the overall system architecture where we'll be giving the input as 32 cattle breed images dataset, and pre-processing feature selection is made, and it will be given to the YOLO V8 model, and we'll be showing with the image based cattle breed detection and webcam based cattle breed detection. This prediction result will be any of the 32 breed names, and we'll be showing the performance analysis and the graph part. And coming to the system requirement, these are all the minimum hardware requirements for the project. And coming to the software requirement, this project can be executed in Windows 10 or 11. Coding language uses Python 3.12.0. Web framework is Flask. Frontend contains HTML, CSS, and JavaScript. And this is the IEEE base paper reference. So now let us see the execution of the project. So just go to the source code folder. Inside that we have the app.py and other file. So just select the address bar and type cmd and click enter. So the command prompt window opens the exact location of it. Now type python space app.py and click enter, and kindly wait for a few minutes. So now you can see the URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it, click enter. So now you can see the project home screen or welcome screen with the project title AI powered cattle breed recognition using deep learning. And here in the home page you can see about the statistics and what all the features that is available information. So it shows about the MAP value, breed, number of breed types, processing speed, detection mode, and features like advanced AI detection, multi-mode detection. As we are going to use upload image and live webcam feed, we are using smart analytics. We will be showing the performance analysis and graph part, and lighting performance and breed description it will be showing, and multi-language voice support. It gives the detection result with the voice report kinds of things. So all these the information has been mentioned in the front end part of it. So now let us log into the system. Just click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and admin. And now after entering the username and password, just enter the login button. So now it will be navigated to the page of the prediction where you can select the mode, whether you wanted image detection, live detection options, and also we have the performance analysis and graph visualization part, and so showing the static key features of high accuracy, fast processing, detailed result, easy to use kinds of thing. Let us see all these things one by one. First let us go to the image detection part. So just select this upload image. It will be navigated to the upload image part, so where you need to choose the image, and after choosing the image you can select the voice output, English, Tamil, Kannada, Hindi or Telugu, whatever you wanted you can choose it. I'll show you with all the things one by one. First let us select the choose image option. So we have provided some sample test images. So just go to the test images folder. So we have just given the few images with the name of the classifications, all these things. Let us show you with all those things one by one. First let us go to the first image, and let me select the image as English or voice output as English, and select the detect breed.
Alambadi, origin, native to Tamil Nadu region of southern India. Breed type, indigenous draft type breed. Physical characteristics, strong muscular build, usually dark or grey coat. Long face and straight horns. Highly resistant to harsh climate. Milk yield, low to medium milk yield. Special features, check mark excellent draft power. Check mark very hardy and disease resistant. Check mark performs well in hot dry climates.
So now you can see after giving the detect breed, so it shows the image that we have uploaded, and you can see the percentage of it, and you can see the detection breed is Alambadi, and what is the confidence rate of it, and what is the origin, breed type, physical characteristics, milk yield, and special event. And also it says the voice output. You can just give second the you can hear the voice output of it also. So if you wanted to predict again, just select this predict again menu. So now it will be loading this image page again. So now I'll just show you with the another case, and now I'll just select the language as Tamil, and let me select the detect breed part.
Amrit
தாஜ்மஹால் தோற்றம் கர்நாடகா இந்தியா இன வகை உள்நாட்டு வரைவு இனம் உடல் பண்புகள் ஒல்லியான தசை கச்சிதமான உடல் பொதுவாக சாம்பல் அல்லது வெள்ளை கோட் வலுவான கால்கள் மற்றும் இறுக்கமான தோல் அதிக சகிப்புத்தன்மை மற்றும் வேகத்திற்கு பெயர் பெற்றது பால் மகசூல் குறைவு முதன்மையாக வேலைக்காக பயன்படுத்தப்படுகிறது சிறப்பு அம்சங்கள் அடர் வெள்ளை நிற டிக் சின்னம் இராணுவ தளவாடங்களில் வரலாற்று பயன்பாடு அடர் வெள்ளை நிற டிக் சின்னம் களப்பணிக்கு சிறந்த சகிப்புத்தன்மை.
So now you can see it has predicted as Amrit Mahal, and you can hear the voice in Tamil language as we have selected the language as Tamil. So let me go to the predict again. I'll just choose the next case with the sample image. Let me select image as Kannada and let me select detect breed.
ಬನ್ನಿ ಮೂಲ ಬನ್ನಿ ಹುಲ್ಲುಗಾವಲುಗಳು ಕಚ್ ಗುಜರಾತ್ ತಳಿ ಪ್ರಕಾರ ಹೆಚ್ಚು ಹಾಲು ನೀಡುವ ಎಮ್ಮೆ ತಳಿ ಭೌತಿಕ ಗುಣಲಕ್ಷಣಗಳು ಮಧ್ಯಮ ಗಾತ್ರದ ಕಪ್ಪು ದೇಹ ಚೆನ್ನಾಗಿ ಅಭಿವೃದ್ಧಿ ಹೊಂದಿದ ಕೆಚ್ಚಲು ಮತ್ತು ಬಲವಾದ ಕಾಲುಗಳು ಹಾಲಿನ ಇಳುವರಿ ಪ್ರತಿ ಹಾಲೂಡಿಕೆಗೆ 1500 ರಿಂದ 2500 ಲೀಟರ್ ವಿಶೇಷ ಲಕ್ಷಣಗಳು ಚೆಕ್ ಗುರುತು ಬಟನ್ ಕಠೋರ ಬರ ಮತ್ತು ಮರುಭೂಮಿಯ ಹವಾಮಾನಕ್ಕೆ ಹೊಂದಿಕೊಳ್ಳುತ್ತದೆ ಚೆಕ್ ಗುರುತು ಬಟನ್ ಅಧಿಕ ಕೊಬ್ಬಿನ ಹಾಲನ್ನು ಉತ್ಪಾದಿಸುತ್ತದೆ.
So now you can see it has predicted as Benny, and also it has given the voice output with the Kannada language that I have selected. So now let me go to the predict again part. I'll just choose another class of image and let me choose this, and this time I'll just select Hindi and let us detect the breed.
बरगुर मूल बरगुर हिल्स तमिलनाडु नस्ल का प्रकार ड्राफ्ट नस्ल शारीरिक विशेषताएं सफ़ेद धब्बों के साथ लाल भूरे रंग का कोट सतर्क और सक्रिय स्वभाव दूध की पैदावार कम विशेष विशेषताएं चेकमार्क पहाड़ी और वन क्षेत्र के काम के लिए उत्कृष्ट.
So now you can see it has detected the breed as Burgur, and the breed details have been shown, and also it has given the voice output in Hindi as we have requested it. And let us go to the breed again, predict again part, and let us select for the other case and let us check it out. Now for this case I'll just select the language as Telugu. Let us detect the breed.
బ్రౌన్ స్విస్ మూలం స్విట్జర్లాండ్ జాతి రకం అన్యదేశ అధిక పాడి జాతి భౌతిక లక్షణాలు బ్రౌన్ నుండి గ్రే కోటు పెద్ద మరియు బలమైన శరీరం పాల దిగుబడి చాలా ఎక్కువ మంచి జున్ను నాణ్యత ప్రత్యేక ఫీచర్లు తనిఖీ గుర్తు బటన్ ప్రశాంతమైన స్వభావం తనిఖీ గుర్తు బటన్ అన్యదేశ జాతులలో వేడిని తట్టుకుంటుంది.
So now it has predicted the breed as Brownses, and also you can see the information of the breed, confidence rate and everything is shown, and also it has given the voice output in Telugu as we have requested it. So now let me go to the predict again part, and now let us go to the other class of the breed and let us detect the breed.
Dangi origin hilly regions of Maharashtra.
So you can see it has predicted as Dangi again. So let us predict again, and I'll show you with the other case. So now let me select the image and go for detect breed. So I'm just cutting out the voices part because to make the video shorter, if I'm just
origin Maharashtra and Karnataka.
So you can see it has predicted correctly as Denoy, and let us predict the class, Let us predict this.
Gir, origin, Gir forest region, Gujarat.
So I'm
Breed
just
type.
stopping the voices because to make its process soon, I'll just show you all the classes so that only. So whenever you are checking, you can check with the all the images that is available.
Guernsey, origin, Guernsey Island.
So it has predicted correctly as Guernsey. Let us go to the another class and check it out.
Kangayam, origin, Tamil Nadu, Kangayam
So
region.
now you can
breed
see.
type, strong draft breed.
So now you can see there was multiple images and so it has predicted wrongly. So this kinds of results also will come. So because it is not 100%, the model is not 100% perfect. So let us show with some other image.
Halikar, origin, Karnataka, India.
So now you can see it has predicted correctly as a Halliger now. Let me go to the predict again part and let me go to the another class and show you.
Haryana, origin, Haryana.
So this has predicted correctly as Haryana. Now let me go to the predictor again. I'll just go to the next class and detect.
Holstein Friesian, origin, Netherlands, breed.
So it has predicted correctly as Holstein Friesian. Let me go for the other class.
Jafarabadi, origin, Gujarat, India.
So it has predicted correctly as Jafarabadi. Let me go for the other class quickly.
Jersey, origin, Jersey Island, UK, breed
So
type.
it has predicted correctly as Jersey. Let me go to the another class of image. Let me select this Stammer. Let us detect breed.
காங்கயம் தோற்றம் தமிழ்நாடு காங்கயம் பகுதி இனவகை வலுவான வரைவு இனம்.
So now you can see it is predicted correctly as Kangayam. And now let me go for the another class and let us detect the breed.
Kankre, origin, Gujarat and Rajasthan regions.
Now it is predicted correctly as Gangrage. And let us go for the another one.
ಕಾಸರಗೋಡು ಮೂಲ ಕೇರಳ ಭಾರತ್.
It is predicted correctly as Kasargod. And let us go for the next class.
Khillari, origin, Satara and Sangli regions.
So it has predicted as Killary. Let us predict another class.
Malnad Gidda, origin, Western Ghats.
So it has predicted correctly as Malnad Gidda. And let us go for the next class.
Nagori, origin, Rajasthan.
It is printed correctly as Nagori. Let us go for the next class.
Red Sindhi, origin, Sindh region.
This is given wrong prediction as Red Sindhi. Let us change some other image and give it.
Haryana, origin, Haryana, India.
So this is also given the wrong result. So now let me give some other image for this.
Nagpuri, origin, Maharashtra.
So now it has printed correctly as Nagpuri. Let us go for the next class.
Neeli Ravi, origin,
It
Punjab.
has printed correctly as Neeli Ravi. Now let me go for the next class.
Nimari, origin, MP.
So it is printed correctly as Nimari, and let us go to the next class.
Ongole, origin, Andhra Pradesh.
So it is printed correctly as Ongol. Let us go for the next class.
Pulikulam, origin, Tamil Nadu.
So it is printed correctly as Pulikulam. Let us go to the another class.
Red Dane, origin, Den.
It is printed correctly as Red Dane.
Gir, origin, Gir forest
So
region.
it has given a wrong result now. Let us choose another image for this class.
Red Sindhi,
So now
origin, Sindh region.
it has printed, now it has printed correctly as Red Sindhi. Now let us go to the next class.
Gir, origin, Gir forest region.
So now it has given some wrong result. So now let us select some other image for this class. Let us predict it.
Sahiwal, origin, Punjab region.
So it has predicted correctly as Sahiwal. Now let us predict the another breed.
Tharparkar, origin, Thar desert.
Now it is predicted correctly as Tharparkar. Now let us predict another breed image.
Toda, origin, Nilgiri hill.
So it is predicted correctly as Toda. Let us go for the another breed.
Umblacheri, origin, Tamil Nadu coast.
So it is predicted correctly as Umlecheri. Let us go for the final 32nd class and let us select the image and predict.
Vechur, Origin, Kerala.
So it
Breed,
is predicted correctly as Vichu. So in this way you can just predict. So to make the video quicker, I have just cropped the voice parts and show you. So I have collected each image from each class and I have shown you. So in this way you can check with the images that is available in the train, test and validation part. So you can just select the images whatever that is given here. So randomly you can select whatever the images you wanted and it will be predicting the result for it.
Haryana. Origin, Haryana.
So in this way you can check with the other cases. So now let us go to the next part, that is the live detection part. So live detection means you don't need any external hardware, just web camera is enough. So first connect your web camera. So before clicking this, so make sure that your web camera is connected. I'll just connect my web camera. Now after connecting your web camera, make sure that your camera is working. So my camera is working. So now let me click this start webcam part. So now it will be navigated to the live detection page. So in the live detection you just need to select the start webcam. In case if the browser asks for permission, you need to allow that permission, then only the webcam part will be activated. So now let us make the screen into two parts. So the right side will be the detection part. So left side, let us keep the images for the detection. So I'll just keep some images to detect. So it will take some time for activating the camera, so kindly wait till it is come, it will be processing. So meantime you can arrange these images and keep your screen in two parts, like one part showing the image and other part as the detection part, or you can use your mobile or some other systems also if you have multiple devices. So based on that you can predict the results. I'll show you that. Now the webcam is activated. It takes some time, so kindly wait till it is activated. So now let us show the images part and let us see. So make sure that your webcam is in good quality and also you are showing the image without any shakes in it. So now you can see it has predicted correctly as Alambadi. So when there is some shakes in it, so it cannot predict correctly. So you need to keep the camera in very steady state so that it will be detecting it. So now let me open some other image and check it out. So now you can see it is predicted correctly as Amrit Mahal. So now you can see it is predicted correctly as Bunny. So now you can see it is predicted correctly as Bagur. So now you can see it is predicted correctly as Ongol. So now you can see it is pretty correctly as Vichu. So in this way you can use your web camera and show different images in the test, train or validation, whatever the thing you can able to show it, and you can able to detect it. So now let me stop it. Now after clicking stop web camera, the web camera will be stopped. So now let me go to the back to home, and now if you go to the modes page where you can see the next one, we have seen the image detection and live detection. Now let us see the performance analysis part. So just select the view performance button. So now you can see the model performance analysis, which shows the detailed metrics and evaluation for YOLO V8 cattle breed detection. So as mentioned, we have achieved the overall accuracy of MAP as 73%, and here the average processing time that is mentioned is 110 microseconds, which depends upon the CPU or GPU speeds, and precision score is 80%, recall score is 63%, F1 score is 70%, MAP at 0.5 with 0.73, which is the standard object detection accuracy score. And you can see the training performance, that is training loss and validation loss graph, and you can see the precision recall curve and shows the per breed performance with the breed name Gir, Sahiwal, Red Sindhi, Tarkpar, Ongol, Kangaraj, Halikar, Kangeyan kinds of details with the precision recall F1 scores of it, with the performance of it. And you can see the model configuration here, showing the model architecture as YOLO V8, input size with 640 pixel, and batch size with 16, epoch strain is 100, learning rate is 0.001, total parameter is 3.2 million, and breed type as 32, and training data set around 4803 images. And here you can see the confusion matrix insights, which shows the top 5 breed classification accuracy percentage with Gir, Sahiwal, Kangaraj, Tarkapal and Ongol breeds. So in the performance analysis, we can see the performance analysis parameters of these things. So coming back to the mode types class, you can see the final thing, that is graph visualization. So just select the open graph. So here you can see the different graphs that is generated by the model part. So YOLO training result visualization. So here you can see the confusion matrix of the graph, and you can see the precision curve, and you can see the recall curve, F1 score curve, precision recall curve, and label distribution. And you can see the overall training summary of the graph that is generated during the YOLO V8 model training. So coming back, so now we have seen all the modes of image detection, live detection, and also we have seen the performance analysis and the graph part. And let me log out. Before completion, let us see the frequently asked question for this project. So the first question is, what is the main purpose of this project? So the main purpose of this project is to automatically identify the breeds of the cattle using the deep learning model. So we have used two different modes. One is using the image, another one using the real-time web camera. Along with that, after prediction, it should say the breed details in the voice on different languages also. This is the main purpose of this project. Next question, which model or algorithm is used in this project? So we have used YOLO V8, U only, look once version 8 in this project. Next question, how many cattle breeds does this project support? So here in this project we have used 32 cattle breeds. Those 32 cattle breeds are Alambadi, Amrit Mahal, Bandi, Bargur, Brown Swiss, Dangi, Dioni, Gir, Gursasni, Haligar, Haryana, Holstein Friesian, Jafarbadi, Jersey, Kongeyam, Kangraj, Kasargod, Kiliri, Malnad Kidda, Nagori, Nagpuri, Nili Ravi, Nimari, Ongol, Pulikulam, Red Dane, Red Sindhi, Sahiwal, Tarkaparkar, Toda, Ummalcheri and Vichu. So these are all the main 32 cattle breeds. Next question, what data set was used for training the model? So here the data set contains around 4,803 cattle images, which is divided into 4,179 for training, 390 for validation, and 234 for testing purposes. Next question, what is the accuracy of the system? So the model achieved training accuracy of 80% and validation performance MAP at 0.5 with 73%. Next question, can this system perform real-time detection? Yes, that is the main objective and that is the enhancement of the existing system. So we have developed with the webcam based live protection, which will be detecting in a real-time way. Next question, does the system provide breed information after detection? Yes, for the image type we have included the breed identification, and also it gives the voice information. Next question, does the project support voice output? Yes, after detection in the image mode, that will be giving the voice output. User can able to select the voice output in the different languages. We have provided with the English, Tamil, Hindi, Kannada and Telugu. Next question, which technologies were used to develop this project interface? So we have used HTML, CSS, JavaScript, and for the backend server we have used Python, Flask. Next question is GPU required to run the system? No, this GPU is not required to run the system, but for developing the project, so to have to improve the training or to make some new data set to be included, you wanted GPU so that it can improve the training performance and the detection speed. Next question, can this system be used by farmers directly? Yes, the system is designed very simple and user friendly because it should be used by the farmers directly. Next question and final question, what are the real world applications of this system? So the real world application of livestock farm management, veterinary hospitals and colleges, and breed conservation programs, and digital dairy industry solution. These are all the main real world applications for this system. These are all the frequently asked questions for this project. This is all about the project AI powered cattle breed recognition using deep learning, and thank you for watching.